Vortex flow meters are a very common instrument in the industrial production process. Let us introduce the working principle of vortex flow meters. Pipeline systems are used to transport and distribute various substances, including water, oil, natural gas, chemicals, solvents, coolants, food ingredients, pharmaceuticals, compressed air, slurries, and more. Due to the different properties of these fluids, different measurement principles are required. One of these flow measurement methods is based on the vortex principle. This phenomenon exists widely in nature. When water or gas flows through the cylinder, under certain conditions, two asymmetrically arranged vortices will be formed on the downstream sides behind the cylinder. The two rows of vortices rotate in opposite directions and alternate together, like street lights on both sides of the street, hence the name. This phenomenon was first observed by Leonardo da Vinci in the 16th century. Later, the Hungarian physicist Theodor von Karman discovered the physical law of forming vortices, hence the name vortex theory, also known as Karman vortex theory. In our daily life, we can see that these phenomena are based on this principle, such as water flow, the atmosphere, smoke from chimneys, moving vehicles, airplanes, anti-Karman vortex street, formed by fish swimming in water. When this principle is applied to a flow meter, a vortex flow meter is produced. The vortex flow meter installs a resistance body in the center of the pipeline, also known as a vortex sounding body, to make the fluid vortex, and then use a sensor to record the state of the fluid. The higher the flow rate, the higher the frequency of measuring the vortex. This frequency is detected by the piezoelectric ceramic detection element and converted into an alternating electrical signal. After amplification, filtering, and shaping, it outputs a voltage pulse signal proportional to the flow rate or a 4 to 20 mA standard current signal.